Here in this video, we are going to see the concept of ionization of polyprotic acid. Now, what is actually a polyprotic acid? To understand that, let us take some examples. If I take a strong acid like HCl, then how it will give me H plus and Cl minus ions. One side is all that in water. Similarly, if I take H2SO4, what I will get is H plus and SO4 2 minus. How many ions here I will get is 2 H plus ions and SO4 2 minus. If I see this HCl here, I am getting 1 H plus, while for H2SO4 I am getting 2 H plus ions. So I will call this as mono. Mono means 1, and this is a proton, so this is a monoprotic acid. So what is a monoprotic acid, student? An acid that gives 1 H plus ion. Very important to note, this 1 H plus ion is for 1 mole of the acid. If you are considering 1 mole of the acid, here also I am considering 1 mole of acid, but I am getting 2 H plus ions. So you have to always consider 1 mole for the definition. So what is a monoprotic acid? Acid that gives 1 H plus ion or hydrogen ion per molecule of that acid, then it is called monoprotic acid. If I say this, what I will call this, student? This will be a diprotic acid because it is giving 2 H plus ions. Let us take the next example, that is H3PO4. If I see H3PO4, what I will get? 3 H plus ions, right? And PO4 3 minus. So how many H plus I am getting here? I am getting 3 H plus, and so this is a triprotic acid. Whether it is di, tri or tetraprotic, we classify them as polyprotic acids. So we have only two types, that is monoprotic and polyprotic. What is monoprotic? Monoprotic is one that can give one hydrogen ion per or one molecule of acid. And what is a polyprotic acid? A polyprotic acid can be a diprotic, can be a triprotic, depending upon how many H plus ions it gives. So how I can define a polyprotic acid? Acids that can give 2 or more than 2 hydrogen ions per molecule of the acid, they are called as polyprotic acids. Polyprotic acids can be di or they can be triprotic acids. Now let us see the example here, students. So let us see the examples. Here I am considering H2SO4. Now this H2SO4, if you see the molecule, it has 2 H plus. I am considering 1 mole. I am not considering HCl because it is a monoprotic acid, and in one step it will give you H plus ion. So let us see this particular acid. So how it will get splitted first? It will give me HSO4 minus plus H plus. So how many H plus it is giving? This is called as stage 1. In stage 1, it is giving me 1 H plus. Now in stage 2, what will happen? In stage 2, this particular anion, that is HSO4 minus, this is a conjugate, student, it will give me SO4 2 minus and H plus. So the reaction is taking place in 2 steps. This particular molecule where all the H plus ions they are present within the molecule, I will call this as a primary acid, right? If I see this, it has lost its 1 proton, so I will call this as secondary acid. And this third, when it will liberate, then it will be called as a tertiary acid. So if I compare this, Ka value for the primary acid will be much higher as compared to Ka of this acid, because now the tendency to liberate hydrogen here, although fast, but the number of hydrogen giving out will be less. This is based on common ion effect. Let us see the next example, students, and that is H3PO4. You can do this simultaneously. In stage 1, I am writing here stage 1. it will give me H2PO4. I'm removing one H, so I'll put one negative sign here, plus H plus. Now this I will consider, so it will be H2PO4 minus will give me PO4 minus minus, one proton gone, so I will have H. So I will have HPO4 2 minus, or in this way, plus H plus. Next will be HPO4 2 minus will give H will be removed now. So you will get PO4 3 minus plus H plus. So this is how stage 1, stage 2 and stage 3 reaction takes place. If you see this, this is your primary, secondary and tertiary acids. So this is what I will have its dissociation constant as K1 or Ka1. This will be Ka2 and this will be Ka3. Now, if you want to see how many reactions it will undergo, so let us see how Hess law is applicable for this. So, this is in connection with thermodynamics, how Hess law is applicable here, students. If I see this reaction and if I try to add this, the two reactions, what I will get is this HSO4 minus and this HSO4 minus will get cancelled here, and I will add up the two equations. So what I will get is H2SO4 will give me, now this SO4 I am writing, SO4 2 minus plus 1 and 1, that is 2H plus. So the same reaction what we got. So this was a short confirmation to Hess law. Thank you, students.